Students, welcome to the world of chemistry. This is Dr. Vikram Panchal. I am discussing wave mechanics, and in this chapter, this is lecture number 3. In previous lectures, I was discussing about Heisenberg's uncertainty principle, and we have derived this equation, which is also known as Heisenberg's principle, which is delta x into delta p is greater than or equal to h upon 4 pi, where delta x is uncertainty in position of microscopic particle, delta p is uncertainty in momentum of microscopic particle. Or we can write delta x into m delta v is greater than or equal to h upon 4 pi, where delta x is uncertainty in position of particle, m is mass of a particle, and delta v is uncertainty in the velocity of particle. Okay, so this is known as Heisenberg's uncertainty principle. Now, they may ask you numericals based on this equation where h is Planck's constant. And the value of Planck's constant h can be 6.626 times 10 to the power minus 27 unit erg into second, erg multiplied by second, and this is in CGS unit. You must be knowing what is CGS, which is centimeter, grams and second, or it can be 6.626 times 10 to the power minus 34 joule into second. This can be used in MKS system, that is meter, kilograms and second. This you have to remember, and you should know that 1 erg equals to 10 to the power minus 7 joule. Okay, this is the conversion unit. So please remember this, and accordingly you have to use H, Planck's constant. Pi, you must be knowing it is 22 by 7, or you can use 3.14. This is constant. Okay, now delta x, which is known as change in position of microparticle, or it can be percentage certainty. Okay, the unit of delta x could be angstrom, nanometer, centimeter or meter. So you should know the conversion units of each other. That is, 1 angstrom is equal to 10 to the power minus 8 centimeter equals to 10 to the power minus 10 meter, or 1 nanometer is equal to 10 to the power minus 7 centimeter equals to 10 to the power minus 9 meter. Okay, so you should know this. Delta V is known as uncertainty in measuring velocity of microparticle. Again, we are discussing about microparticle only, and this can be percentage certainty. Units will be centimeter per second. It can be written like this also, centimeter second inverse. This will be in CGS unit, and meter per second, or we write like this, m sec inverse or s inverse, which will be in MKS unit. And remember that 1 centimeter is equal to 10 to the power minus 2 meter. Okay, this is a conversion unit. Please remember this. Now the next part is mass of particle. So mass of particle for this the symbol is m, and this mass can be in grams, which will be in again CGS unit, and in kilograms, which will be in MKS unit. So we can use any one of this according to what is given in our numericals. Okay, the value of all this is very important. Now one more conversion you should remember: delta x times delta v, both are uncertainty. So we write this is uncertainty product. This we call uncertainty product, and the unit will be erg into second into gram inverse, or joule into second into kilogram inverse. Okay, so this you have to remember for this. Okay, if delta x is 0, then definitely delta v will be infinite, or if delta x is infinite, then delta v will be 0. Okay, so this is the condition, and we know that delta p is equals to m into delta v, which is called uncertainty in momentum. Okay, so this can be asked, and you should remember that either they can ask you to find out delta p, delta x, m, or delta v, and we have formula with us: delta x times m delta v is greater than or equal to h upon 4 pi. Or if you want to find out delta x, then delta x is greater than or equal to h upon 4 pi times 1 upon m into delta v. Or if you have to find out delta v, uncertainty in velocity, greater than or equals to h upon 4 pi into 1 upon m into 1 upon delta x. Okay, or mass may be m is greater than or equal to h upon 4 pi into 1 upon delta x into 1 upon delta v. Okay, the unit of delta x will be meter or centimeter. The unit of delta v will be meter second inverse or centimeter second inverse, and unit of m could be kilogram or gram. So this way you will be given all of this, and you have to find out one of this term in case of numericals if they ask you. Now let us see numericals. So first numerical, based on Heisenberg's uncertainty principle, the speeds of Kia, you know car, Kia, and BMW cars are recorded to plus or minus 7 into 10 to the power minus 5 meter per second. You know meter per second means what is given? Delta V. Assuming the track distance to be known within plus or minus 20 meter. Again, meter is given, that means you are given delta x. Remember this is the uncertainty principle violated. This is asked for, yes, the weight mass of car. We can assume that both the cars having same mass, then we can say that it is 5 tons. Okay. Now what is given to you? That is very important in case of answer. You are given delta V. First of all, whenever you solve any numerical, please first of all write what is given to you. That will give you a lot of hints what you have to find out. Numericals are very easy. I tell you, you have to write what is given and you will come to know what you have to do. Delta x is given, that is 20 meter. We don't mention plus minus in case of calculating numericals. Mass is 5 tons and you know 1 ton is equal to 1000 kilograms. So it is 5000 kilogram. We are using MKS units because meter per second V is given, delta x is in meter. So we will use H. Again, mass is also in kilograms, so we will use H in 6.626 10 raised to minus 34 joules into second, that is MKS unit. Okay, so the answer will be also in MKS. So delta, first of all, we have to find out which formula we will use. Delta x into m delta v should be greater than or equal to h upon 4 pi. So this is LHS and this is RHS. Left hand side and right hand side. So LHS is equal to delta x into m delta v, which is equal to 20 times 5000 times, 7 times 10 to the power minus 5, and it is 7 kilogram meter square second inverse. Okay, this is LHS. Now RHS is equal to h upon 4 pi. So that is 6.626 times 10 to the power minus 34 upon 4 times 3.14. Okay, so if you will calculate, you may get something which is nearly 10 to the power minus 35 times something, and the unit will be joule into second. Now you can see that the value of left hand side is 7 and right hand side is 10 to the power minus 35. That means left hand side is greater than RHS. That means we are not violating Heisenberg's principle. Therefore, this is the case. So in this case, Heisenberg's principle, uncertainty principle, is not violated. Okay, so this way we can give the answers to this question. So this is it in this lecture. Thank you so much.